Hello, my name is Mark, and I'm going to be doing a problem in regards to elastic collision, heat, and kinetic friction. Okay, the problem reads: a lead bullet of mass 0.012 kilograms is traveling with a velocity initial of 110 meters per second when it strikes a wooden block. The wooden block will be 8 kilograms, and the initial velocity of the wooden block is 0. It's at rest. The bullet will be embedding itself in the block after the impact. They will slide together. Okay, all the kinetic energy that is lost in the collision is converted into heat. Assume that all this heat goes into heating up the bullet. Okay, the first question is, what is the speed of the wooden block after the collision? So for this, we need the formula of inelastic collision, which will be m1 times v naught initial. That's redundant. m1 times v naught of the bullet plus m2 v naught of the wooden block will be equal to the sum of the mass of the bullet and the block times velocity final. Since the wooden block is 0, the velocity of the wooden block is 0, we can take this out, and velocity final will be equal to mass of the bullet times velocity of the bullet over the addition of the two masses. Okay? And we have the velocity final is 0.1647 meters, which is substituted the values. This one for this one for this one, and both masses. Okay? The second problem. How much heat is generated as a result of a collision? For this, we know that energy initial is equal to energy final. This translates to kinetic energy initial plus potential energy initial plus energy thermal is equal to kinetic energy plus potential energy plus thermal energy. Okay? Since the object is moving, we have potential energy, and since there isn't any collision at the moment, we're not going to have any thermal energy. Okay, so this translates to kinetic energy initial is equal to kinetic energy final plus thermal energy. This will be equal to kinetic energy initial minus kinetic energy is equal to energy thermal. Okay, so the formula for this two will be Then we're done with the kinetic energy. All of this is kinetic energy. And then minus is right here. Then kinetic energy final will be half multiplied by by the sum of m1 and m2 times velocity final. Okay, and this will be equal to thermal energy is measured as heat. Okay, and we just need to substitute the values. This will be 0.5 times kilograms times 110 meters per second squared. Oh, remember that this is 0 since the velocity initial is 0. Remember on this side, the velocity initial of a block will be 0. Okay. And then 0.5 times plus 8 times the velocity final, which will be 1647 meters per second squared is equal to Q. So Q is equal to 72.5 joules. Okay, so this is the heat produced by the collision. This is the heat produced by the collision. Okay? Then it's asking us how many degrees does the temperature of the bullet rise after the collision. The specific heat of the bullet is 128 joules over kilograms times Celsius. Okay, so for this, we need to know that specific heat is equal to heat over mass times the change in temperature. And we want to know the change in temperature. So the change in temperature is equal to Q MC. Okay. Let's put in some values. The change in temperature is the heat, which is 72.5 joules over the mass of the bullet times 128 joules over kilograms Celsius. Okay, this will cancel out, this will cancel out, and we're left off at the change in temperature is 47.2 Celsius. Okay. And the last problem. Suppose that the table has a coefficient of kinetic friction of mu is equal to 0.15. What is the acceleration of the block? So we know that friction is equal to mass times acceleration. And friction means that mu times the normal force equals to mass times acceleration. Normal force is equal to mass 1 plus mass 2 times gravity. And we have that mass, in this case, is mass 1 plus mass 2 times acceleration. This means that since these ones are multiplying, we need to pass to the other side dividing. 1 plus mass 2, mass 1 plus mass 2, and this will mean that they will be cancelled out, and mu times gravity is equal to the acceleration. Okay. So 15 times 9.8 meters per second squared will be equal to the acceleration. And this is 1.47 meters per second squared. And that is it. This is all we have to do.